Hello and welcome back to the lab. Today on the bench we have a Wavetek, what are we? A 5 megahertz phase lock generator, model 186. I have a request to get this unit up and running for another technician and see what's going on with it. It's not behaving quite right. Take a look at it here. I know it's not locking in terms of phase, and its output is a little wonky. So we'll get a scope turned on, take a look at the output, and then start tearing it down and possibly rebuilding it. Now I still have a small sample size, so I can't say definitively. However, on the Wavetek units that I've worked on, haven't had much luck with power supplies, things like that. So definitely going to rebuild the power supply in this guy, and then we're going to go from there, see if it needs any other troubleshooting and maintenance. All right, given that we have a transformer on the back, we're going to be able to start this up with a gently on a variac. Doesn't have a switching supply. I'm guessing it has a linear supply. So it should be safe to start up with a variac, and we'll just see what it does. All right, we will keep an eye on the scope and power this up. Give it 300 milliwatts, so nothing catastrophic on the power supply. No shorts. Came down to drawing about 3 watts at 60 volts. Keep going up. We do see the scope trace moving around, which means it's trying to come to life. I very much doubt the capacitor's in here, so it's not gonna... oh, we have some oscillation at least. But it is biased low. So if I ground the signal here, so yeah, we're not oscillating around 0, and we have the offset turned off, and it should be a sine wave. Let's get a bit more here on the scope, and it even went down further. So we have some supply issues, and that is not sinusoidal at all. That looks more like a ramp. That should be ramp. Okay, that changes. Square wave? Kinda. Okay, so we probably have a ripple problem on the power supply, just given the negative offset, which means our positive rail probably isn't as strong as it should be, and having the distortion in there. If I turn it to sine wave, I do have offset controls, so I can move it around, so that's good. So it's halfway got a brain. Attenuator does work, and variable amplitude does work, but we clip. Okay, so as I keep turning up, I'm clipping out at the bottom of the sine wave. We'll zoom in over there real quick. So as I ask for more, I clip out more and more and more. So yeah, I think our negative rail's strong, but our positive rail's kind of out to lunch. These lights are fairly strong. They look stronger in the camera than they do in person, but so not as bad as some of the other ones we looked at, but also not great given the output. So let's get this thing open, and we'll get some caps replaced. Okay, to get the case off, we have 4 nicely long threaded machine screws. These feel like they go into a metal insert. Guy's actually pretty long. So we'll pop the bottom. I think should come off. Is how this works. Yes. Hopefully this is easier to work on than those function generators, because double board construction. Because those function generators are kind of hard to troubleshoot. Okay, looks like I got 4 screws that hold this down to the bottom section. So we'll get those popped out real fast as soon as I find an appropriately sized screwdriver. P1 screws on these. I'm only expecting this to expose bottom side. I see a couple caps I already want to replace. These gray ones typically don't hold up well long term, but we'll have to do an ESR test on them and see. That's 3 of 4, I think. Number 4. All right. Yeah, it's moving. Okay, so this is going to pop out the case. Like so. Oh, there's the power supply section. Nice metal threaded inserts on the case. That's not bad. Okay, so decent number of caps. Looks like it may not be too bad. I think the first thing we're going to try to do is pull these heat sinks off the board, off this back panel, see if we can get the back panel to separate. If I can do that, might be able to get that out of the way, and then I might be able to separate these to get to the underside, because I could do this cap pretty easy, I could do this cap pretty easy. All this stuff in the middle is going to be a pretty nice challenge. The solder doesn't come through to the top on some of them, so I am going to have to get under this to especially get some of these replaced. So there's some on these big guys, the solder comes up to the top. I could work at the top of the front, and also this one looks to be bulging a little bit already. And I don't like the way these look. They're gonna go. So next thing I got to do is I got to get these boards separated. Hopefully, if I'm gonna pop these boards apart, all I should need to do is take this control off, because these will stay on the chassis. And I might be able to separate the boards and get access to them and get those caps replaced in short order. That's going to be the plan. This control is the one that's going to need to come off, because I have this through shaft. On these, the pots are right on the back of here, and then these switches will come out the back with the board, and the power connector I don't need to worry about. So this might actually not be too terrible to get that board separated and actually get into it. On the bottom of this, lots of controls, lots of switches that will need to be cleaned up and serviced to put this thing ready for the long term. But also 2 more caps down here, but if I got the board separated, those won't be too bad. So more teardown. Well, it's tight, but it can be opened for servicing, so I got to leave it up on its edge like this. Fortunately, with all the stuff that I've worked on over the years, I'm used to working at odd angles. If you're uncomfortable working at weird angles like this, you could very easily tear out, desolder some more connections, pull some more pins, and the whole thing will separate and the boards will actually come out. But we're going to try to go with minimal disassembly and see how far we get. So let me get this rotated, and then we'll be able to start servicing. This will also give really good access to these 2 capacitors here to get them swapped out, and then the power caps on the back panel. All right, here we go. A little bit of fresh solder to make the joint easier to melt. That should be one. Yep. And there we go. 1 out, many to go. Ugh, I don't like that. This is a 47 microfarad. Is it a 47? No, it's 100 and a 16 volt. 100 mic by 16, and we read 119. That might be starting to show some leakage. Not as bad as if it was a 47 and measuring 119, so it might be okay, but we're going to replace them for good measure. And 100 by 50 will fit nicely in position here. Gonna do this up the hard way. So solder that first. Straighten the part out, making sure joint doesn't move when it's cooling. That can be where the 63-37% alloy solder works a little bit better. It has a much quicker transition from liquid to solid. Doesn't go through that weird plastic region that the 6040 does. So use up any 6040 solder you've got, but if you're going to reorder it, unless you really, really like 6040 solder and like it and need it for a specific use case, get the 6337. Much better solder to work with. There are certain times where specific alloys of solder are necessary. One of the ones that comes to mind while we're working on this is Tech ceramic strips. That needs some silver content in there to keep from breaking the silver to ceramic bond. So when those are needed, obviously use the appropriate solder. All right, here we go. Okay, you guys don't need the, I don't need to bore you guys with just soldering. So I'm going to flip on some music. We're going to hit this board hard, get all the caps refreshed. I'm going to bring you guys back through the magic of the camera. We'll have 2 recapped boards. One thing that's kind of wild about this unit, as I've been working on it, is we have a mix of plated and unplated through, or we have a mix of non-plated and plated through holes. So right here, we have one of the larger power caps. It was a 500 microfarad by 50 volt. Big guy. And we have a plated through hole for that capacitor. But for some of the smaller caps, especially over here, the ones we were working on, these had non-plated through holes. So just interesting when the unit was made, things like that. It's an era where plated through holes were actually a considerable cost to board manufacturer. So they only used them where they deemed necessary to keep cost of the boards down themselves. It was kind of a dollar value engineering. Now they're ubiquitous. I mean, you can't, even as a prototype board, you'd order plated through holes because it doesn't add any cost at all. But that was not always the case. Okay. I have been tearing my hair out over this thing for a little while, and I think I finally figured it out. So I was going to do a power on test just to make sure everything worked, and I fired it up and nothing did. The rail was stuck at an extreme end. I also got into a situation where the test equipment was lying to me. It was showing me oscillation, and I even had a extremely fast oscillation at the on the power output. It was oscillating at about 120 megahertz, which is strange. This thing is not even supposed to go that fast. So that started the troubleshooting process, and I ended up finding out that the main oscillator was not running. Main oscillator on this particular unit is this op amp hiding up in here. And I swapped that out with a socket. If you need to check to see if the main oscillator is running, you can pick up the signal on pin 8 of this transistor array. I'm not a fan of these transistor arrays, but they used them in here. Nothing I can do about it. These sockets are also kind of junk. I do have to go back in again, and if it is oscillating again, I may change it back. I even switched back to the older capacitors, thinking that may help the supply a little bit. When we get into the gear lying to me, I did need to break out the differential probe because if you hook the ground lead to your scope here, I saw oscillation. It was low, but it was there, and my frequency counter was having a hard time locking onto it. That should have told me something, and I was tearing my hair out for a little bit. Essentially, what that was seeing was it was seeing 60 hertz noise come in to the chassis. So what I had to do is get the differential probe. That let me start doing some measurements. And I did a power measurement on this op amp, and I was only getting 14 volts. The weird thing with getting 14 volts there, I should have had 30 because it's a 15-15 supply going across the supplies just to make sure the op amp is sane. Should have 15, but I had 14 and plus 1, which was kind of strange. Now, if I measure at this capacitor where I'm supposed to, I get my full negative supply. Everything is good to go. However, this is what's got me tearing, or this is what had me tearing my hair out, and what we're about to dive in and fix again. Power this back up. If you're going to work on a bench with stuff plugged in, take all appropriate cautions, as there is 110 and derived voltages everywhere. This is a low voltage box, although I can't come across 50 volts because it's a plus minus 24 volt rail on the output. Where's the power button? There it is. So if I turn this on, this center pin is ground. And if I touch this pin, we should have plus 15 volts. And we do, as we can see on the DMM, plus 15. This is my negative 15 volts. Not negative 15 volts. So I lost my 15 volt rail, and the weird thing is I lost my 15 volt rail somewhere between here and here. So I have negative 15 volts at the capacitor. I don't have negative 15 volts on the pin to go down to the other board. So we'll pop this out one more time, see what we can do to get that fixed. But I'm assuming a cracked solder joint around that pin is my ultimate problem, but we will see. I also have no continuity between that pin and that capacitor, so the 15 volt rail cannot get to the negative 15 volt rail cannot get to the bottom board. So, tear it apart again. Well, that might explain why it's not working. Right there, that's a dry joint. So, I'd be willing to bet, well, I'm sure I didn't solder something. Put some solder on that and see if I have continuity of that power pin. All right, the proof is in the doing. Here's the negative supply. Beep. Okay. So, you know what? It really helps when you make all the connections. All right, let's see if we have function. Frequency counter's on. I'm asking for a 1 kilohertz sine wave of a varying amplitude. No idea. AC on the scope. Here we go. It works. All right. Well, that looks infinitely better already. Drawing about 17 watts, which is probably right. And actually, it's pretty bang on. You guys can't see that. I need to move you up. It's pretty bang on 1 kilohertz. Yeah. Not unhappy about that. Yep, I can DC offset the waveform. Half top square wave, plus minus square wave, triangle and sine. Everything looks good there. Biased a little bit low, but I have to do an alignment and a calibration on here, so I'm sure that's going to clean up there. Very cool. We should have 1 kilohertz out over here. Let's see. This should get pulses out now, I think. Yep, there they go. That's our TTL output at 1 kilohertz. And then we should get a 1 kilohertz sinusoid out of here. Yes, we do. All right, so everything is looking good. So the front's working. We'll see if we can lock phase and go from there. But it at least has half a brain. Okay, with the signal coming in from the Rigol into the phase lock input like it's supposed to and going up to the scope, we do have phase control. So that is working, and that is actually the reason for all this effort to get this particular unit fixed. Is we want to, and I have phase control over that signal. So that is excellent. There is still something that I need to check in the output amplifier, because if I turn this all the way up, well, it looks a little distorted now, but not terrible. So it's probably just a output centering problem. Oh no, it was when when I gave it a load. If I give it a 50 ohm load, it's only showing me half the output. So that's going to be probably one side of the transistors is struggling, maybe when transistors shorted out or something. So we'll see what we can do to get that squared away. Okay, so we do have a 8 volt peak to peak sine wave at 50 ohms. It's supposed to be 7.5, so we are hitting spec there. I do have a little bit more adjustment, and I can clip the bottom off. I checked all the power output transistors. They are working fine. They are absolutely horrifically matched, but they're working. If we take a look at the PCB, we have our PNP transistor and our NPN transistor. The NPN transistor has a HFE of about 147. The PNP transistor has an HFE of 10. So they are quite awfully matched. These two are actually a little bit better matched, but that's where I'm getting some of the biasing. I do have a little bit of control over here, but I have to do a full alignment on this because I'm sure the waveform's not centered anymore, and it should be. So I'm sure that's affecting the output given the design of this generator. So we're going to need to hit all the test points and get everything squared away. It's getting a little late to warm up the Cal gear tonight, so we're going to call it there for now, and I will be back tomorrow. Okay, the lamp problem was a transistor that had a cracked solder joint as I was moving things around. So we are ready for burn-in testing. Essentially, I got to put the covers back on. I'm going to let this thing cook for most of the night. And if it doesn't flake out, then we'll be ready to start an alignment. I'm also waiting for the rubidium to kick on. I had it off and cold for a while, and with the rubidium being off, it is lost the sync to the 1 pulse per second. Now, it's locked to the rubidium, so it's 10 to the -12 stable, which will be fine for this particular unit, so we can start the alignment once all the gear warms up and it goes through a burn-in testing. But we'll get that started now, and then hopefully no smoke. All right, after a bit of extensive alignment, it did turn out the offset problem that I was having was some significant problems with the alignment on the VCA, the preamplifier, and the output amplifier. A lot of the offset was in the VCA amplifier, so step 8, 12, 10, and 9 were what was needed to bring that back into balance. But we'll move over to the scope here real fast. We have a very nice looking sine wave, fairly well centered, and 0.5% THD, so not too bad. Thanks for stopping by the lab and taking a look at this Wavetek Model 186. Got another piece of test gear up and running. We have a destination for this one already, so I know where this one's going to end up. But as always, more is on the way. If you'd like the content, hit the subscribe bell button, all the YouTube things, and also check out the Patreon page. Patreons are running a little bit ahead of YouTube. Right now there is nothing behind the paywall, but they get some behind-the-scenes looks at what's going on in the channel, and also videos as they're edited. Their support is, I'm eternally grateful for all the support that the Patreons have provided to the channel. They help keep the lights on in the lab, and YouTube, and videos coming up to YouTube. So with that, I'll see everybody in the next video. As always, more is on the way.